morning, learners. Welcome to a new video on network crashing, which is a technique used for reducing the total duration of a project in project management. Okay, so in this case, a problem is given and we will be solving the problem to find out the minimum cost and optimum duration of the project. That is the problem we are going to solve today. So to find out the minimum cost and optimum duration, for finding out the optimum duration, we need to crash the network. Crashing the network means we will be reducing the time of the total duration of the project. How can we reduce the total duration of a project? By providing or supplying more materials, more labor, and more machinery whenever it is needed. Extra money will be needed for completing the project in a shorter time than it was planned. Okay, so in this question we are given with this data you can see here. So the data given are, there are 9 activities from A to I, and their corresponding node connections are also given. That is, for activity A it is 1 2, activity B 1 and 3 are connected, and the activity C is 1 4, etc, etc. And for all these activities we have the data, that is Tn. What is Tn? Tn means the normal time duration. That is, if we are trying to complete the activity normally, that is without crashing or without reducing the time. Okay, uh, or we can say in ideal conditions as per the initial planning, it will take 7 days. But if we supply more materials, labor, etc., if you want, we can finish it in 4 days. That is the tc means crash duration. So activity A can be the duration can be minimum 4 days. Okay, less than 4 days the activity A will not be able to complete it. Okay, so similarly for B also, 5 and 3, that is normally it can be completed in 5 days, and minimum 3 days is needed. Like that, all those TC values for all the activities are given. Say another one is Cn. What is Cn? Cn means the normal cost. Normal cost means if the activity is A, for example, if activity A is completed in 7 days, that is normal completion, means it will cost 700 rupees. But if it is crashed to 4 days, then it will cost 850. Okay, if it is crashed, then it will cost 850 rupees for activity A. Clear? So similarly for other activities also. So we have Tn, Cn, Tc and Cc. Cc means crash cost, Tc is crash time, then crash duration, and Cn is normal cost, and Tn is normal time duration. Clear? Now, to solve the problem of network crashing, the first step is to find out this cost slope of each activities. Cost slope of each activity. So cost slope is calculated using the equation. Cost slope S is equal to Cc minus Cn by Tn minus Tc. This is the equation. Cc minus Cn by Tn minus Tc. That is the equation used for finding out cost slope of an activity. Say for example, slope of A, cost slope of A is SA is equal to Cc for A is 850 minus Cn. Cn is 700 divided by Tn. Normal time is 7 minus crash time is 4, and that is equal to 150 divided by 3 equal to 50 rupees. 50 rupees is the slope of activity A. Clear? So this is 50. Similarly, for the other activities, we can calculate like this. It will be 100, 200, 225, 150, 200, 125, 100, and 350. So these are the cost slope of all the activities. We have calculated using this equation. S equal to Cc minus Cn divided by Tn minus Tc. Clear? So all the values we have calculated here. Okay. Now, next step is to draw the network diagram. To draw the network diagram. How can we draw the network diagram? So, 1, 2, 1, 3, 1, 4 are first three activities. So, it is starting from node 1. The three activities are starting from node 1. Say node 1, 1 to 2, 1 to 2, 1 to 3, and 1 to 4. These are the first activities. That is 1, 2, 3, 4. Okay, 1, 2, 3, 4. Then D means 2 to 5. 2 to 5. Then E is 3 to 5. Okay. F is 3 to 6. And G is 4 to 6. Then H is 5 to 7. I is 6 to 7. So these are the activities. 5, 6, and the node is 7. Okay. Then for activity 1, 2, the normal duration is 7. Normal duration is 7 and the crash duration is 4. For activity 1, 3, it is 5, 3. For activity 1, 4, it is 8, 5. Okay. For activity 2, 5, it is 9, 7. For activity 3, 5, it is 5, 3. Activity 3, 6, it is 6, 5. Activity 4, 6, it is 7, 5. And 5, 7, 2, 1. The 6, 7, it is 3, 2. So these are the activity durations for each activity that is written over the activity arrow. Okay. Now, from this diagram, we can determine what are the critical paths. Okay. What will be the critical path? Critical path will be the longest path in the network diagram. So let us consider the possible paths in the network diagram. The first one is path 1 is 1257. 1257, and its duration will be 1257. The normal duration will be 7 plus 9 plus 2. That is 7 plus 9, 16 plus 2 is equal to 18 days. And second path is 1357. And its corresponding duration will be 5 plus 5 plus 2 is equal to 10 days. And the third path will be 1367. And its corresponding total duration will be 5 plus 6, 11 plus 3, 14 days. And fourth one will be 1467. And its duration will be 8 plus 7, 15 plus 3 equal to 18 days. Okay, so these are the possible paths in this network diagram. And from this total duration, we can find out the critical path. We can find out the critical path, which are the critical path. The longest duration is 18 for the first path, and for 4 also, path 4 also it is 18. So these are the critical paths. So the total or the project duration is equal to 18 days. That is normal. Normal project duration is 18 days. Okay. So if the normal project duration is 18 days, we can calculate the normal project cost. Okay. In the problem, the indirect cost is given as rupees 200 per day. Rupees 200 per day. So if indirect cost per day is 200 rupees, then the total cost will be the total project cost will be, that is normal project cost will be 6,500. That is this value, that is a sum of CN values, 6,500 plus 18 into 200, that is in the direct cost plus indirect cost. Okay, direct cost plus indirect cost. So this is equal to 6,500 plus 18 into 200 will give you 10,100 rupees as the total cost. Okay, the total project duration is 18 days, and if you complete this project in 18 days, the normal total project cost will be 10,100 rupees. Now we can try to minimize the cost and we can find out the optimum duration of completion of the project. Okay, completion time of the project. For that we have to crash the network diagram. Okay, so here we have two critical paths, the first one and the fourth one. So I will mark the critical paths like this. This is critical path 1, critical path 1 for the activities. This is critical path 2. Okay, so 1257 and 1467 are the critical paths having 18 days duration. So to crash these paths, as we know, if there are more than one critical paths, then each critical path must be crashed simultaneously. Both them, if there are two paths, both of them must be crashed simultaneously and also by the same duration of time. Okay, otherwise, say for example, if you consider, say, so we have one path of duration 18 and a fourth path of duration 18. If we reduce, say, the second one, that is fourth path, by 2 days, what will happen? This will become 16 days. Okay, but the problem is the total project duration will be 18 again, is it not? This will be the project duration because this will become the largest path. This will become the largest path in the network diagram, and this 18 days will be taken by the project to be completed. So therefore, we have to reduce this also into 16, that is by crashing by 2 days. So in this problem, we have two paths of same duration, that is they are the critical paths. So we have to select activities from each path and we have to reduce through the same days. Okay, so how to select the activities for crashing? There is a condition that for crashing an activity we have to select a path which is, or an activity which is having least cost slope. For that, we have already found out the cost slope here. So we have here the slope of all the activities found out using the equation. The equation we know, that is S equal to Cc minus Cn by Tn minus Tc. We found out all these things, and using the cost slope we can select activities for crashing. Okay, so for the path 1257, that is the first path, the activities are 1, 2, 2, 5 and 5, 7. Corresponding cost slope are, for 1, 2 it is 50, and 2, 5 it is 225, and 5, 7 it is 100. Okay, for the second path, that is 1, 4, 6, 7, 1, 4, 4, 6, 6, 7, the cost slopes are 1, 4 is 200, 4, 6 is 125, and 6, 7 is 350. Okay, so out of this, which activity we have to select? From both these paths, we have to select an activity. Select activities, one activity each. That is, activity should be selected in such a way that the cost slope should be the least one. Okay, from these three activities, we have to select an activity which is having least cost slope, because if we select say 225, the cost will be more. Okay, so that we will not be getting a minimum cost, or an optimum cost we will not be getting. So for getting an optimum or minimum cost, we have to select an activity which is having least cost for cost slope for crashing the activity. So here we can see 50 is the minimum one. So we should select 1, 2 activity A for crashing from for first path 1 and path 4. Okay, path 1 and path 4. So path 4, we have three activities, and out of this we have the least cost slope for 4, 6, that is activity G. So this is having least cost slope, and for path 4 and for path 1, this 1, 2 or activity A is having least cost slope. So we will select this activity for crashing in the second path, second critical path. Okay, so how many days we can crash? Look at the normal time and crash time for activity 1, 2 for the first path. So here the difference between normal and critical time is 3. Okay, so we can, at the maximum we can crash by 3 days this path. And what about this path? This path is 7, 5, difference is 2 only. So you can crash this path by 2 days only. Okay, for this step. Okay, but the problem is if we select 3 for both the paths, this will not work out. Okay, so what we can do is for path 1 also we will select as 2 days of crashing. 2 days of crashing. Okay, so it should be same, it should be simultaneously, and using the same crash time, it should be crashed. Okay, so 2 days will be crashed for path 1 and path 2. So activity 1, 2 will be crashed by 2 days, and activity 4, 6 will be crashed by 2 days. Okay, so now if we crash these paths by 2 days, the new project duration will be equal to 18 minus 2 equal to 16 days. 18 minus 2 is equal to 16 days, isn't it? New project duration. Now, new total project cost is equal to the previous cost, that is 10,100 plus 10,100 plus what is the extra amount incurred in crashing these two activities. That depends upon the number of days and cost slope. That means for the first path, activity 1, 2, it is 2 into 50. 2 days is crashed, and 50 is the cost slope, plus 2 into, here it is 125. Then minus, as we have reduced the time from 18 to 16, 18 days to 16 days, we have some benefit of in indirect cost. That is, indirect cost will be just for 16 days. That means 2 days of indirect cost can be subtracted from this. That is minus 2 into 200. Minus 2 into 200. And this will come to around 10,050 rupees. The total cost will be 10,050 rupees. So the new total project cost will be 10,050 rupees. Now we will try to crash the network again by selecting two activities, and we will, so the total project duration is 16 days. Now as we have crashed the network by 2 days, then the total project cost will be 10,050 rupees. Now we will try to crash it again, so that we will see if we can crash it again, and some lesser duration, and the cost will reduce. If the cost is not reducing, we will stop here, and the duration will be, the optimum duration will be 16 days, and the total cost, the minimum cost will be 10,050 rupees. Okay, so next step, that is, now that duration is 16, we will check which are the critical paths. Now the critical path is, that is 1, 2, 1, 2, 5, 7. the path is, another path possible is 1. First path is 1, 2, 5, 7. Its duration is, this will become 5, 4, and this will be 5, 5. 5, 5. Okay, because we have crashed by 2 days, right? So for the first path, it will be the duration will be 5 plus 9, 14 plus 2, 16. And second path, 1, 3, 5, 7. It is 5 plus 5 plus 2 is equal to 1, 3, 5, 7. It is 12. Third path, it will be 1, 3, 6, 7. It will be 5 plus 6, 11 plus 3, 14. And the fourth path, it will be 1, 4, 6, 7, and the duration will be 8 plus 5, 13 plus 3 is equal to 16 days. 16 days. Okay, so these are the new paths, and out of this, first and last, as in the previous case, first and last are the critical paths having duration of 16 days. Total duration of 16 days is for first and fourth, and they are the same, paths are the same. Okay, so this is 16 days as the project duration. So now we will select the crashing again. So for the path 4, you cannot select the least cost slope, that is activity 4.6, because we have already crashed it to the maximum possible. That means now there is no availability of crashing time. So we have to select the next lowest cost slope activity. That will be activity 1.4, having 200 as the cost slope. 200 as the cost slope. Then in the first path, it will again be 50, because there is a possibility of crashing by 1 day. Okay, 1.2 can be crashed by 1 day again. Therefore, you will select the same first activity, that is 1.2, activity 1.2 for crashing. Its cost slope is 50, which is the least one. Okay, so we will do the crashing. The new project duration is 16 days. If you select it by 1 day, that is, you can select 1, and for 1.4 it will become 7.5, and this will become 4.4. So it will become 4.4. Right here, its new duration will become 4.4. Okay, it will be 4.4. Okay, now let us see the total duration will be, new project duration will be 15 days. Is it not 15 days? Because 4 plus 9, 13 plus 2 is equal to 15. Okay, right? So that will be the one critical or the project duration, and the new project cost will be equal to the previous total cost, that is 10,050 plus 1 into 50, that is 1 into 50 plus 1 into 200 minus 1 into 200. Okay, this 200 is the crash cost for activity 1.4 for crashing for 1 day. Crashing for 1 day. This is crash cost slope for activity 1.2 for crashing 1 day. Okay, and this will be the savings in indirect cost. That is, if we reduced 1 day, 2,200 rupees will be reduced from the total indirect cost. Okay, so that we have to subtract. So this will be coming around, and this will be cancelled, and it will be equal to 10,100. It will be 10,050 plus 50 is equal to 10,100 will be the total cost. Okay, now just compare with the previous one. It is 10,050 and this is 10,100. That is, when we crashed the new network diagram, by 1 day, the cost increased. The cost increased. That means uh, this is not the minimum cost. Okay, and the minimum cost is 10,550, 10,050, and corresponding to that minimum cost, the duration will be the getting duration will be the optimum duration, and it is 16 days. Okay, so optimum duration is equal to of the project is equal to 16 days, and minimum cost is equal to 10,050 rupees. Okay, so the project can be completed in 16 days with a minimum or optimum or minimum cost of 10,050 rupees. Okay, so that is the procedure of crashing a network, and in this case there were two parallel critical paths. If there are two parallel critical paths or more than one critical path, then all the critical paths must be crashed simultaneously and by the same amount. Otherwise, there will not be change in project duration. We need to change it or reduce the project duration. That is the purpose of crashing, and we have to get the optimum time or minimum time and optimum amount. Okay, thank you.